Okay guys, welcome back to the last and final video of this session regarding absolute value and exponential functions. This is the fourth video and final one of the week. Let me start just by reminding all of you guys that we've been working in the following way. You should watch the complete video, and also if you need, please pause and go back at any point if you want to redo or rewatch a section of an exercise. Remember that there are a lot of exercises involved, so you can use those exercises as a practice and then wait for me to solve the exercise to check. Also, remember that other students are working at their own pace and time, so please be patient with them. Take your time, and then I'm not expecting all of you guys to work at the same pace. If by some reason I have to come back later to redo some of the exercises, it's perfectly fine, but I would like you guys to try your best to ask questions to others and try to reach the same solution with the problem. And don't forget, you have to show your evidence of your work in Google Classroom. The assignment is there for you guys to upload a picture of your work. Now, let's continue. Up to this point, we talked already about composite functions. That's already done. We did a few exercises in which you guys were drawing absolute value by using tables and your calculators. Then we started working with exponential functions. The good thing about it also is that we did tables, we worked with the function itself, and then we also used the calculator to check that the graph had this shape. And then finally, I showed you guys a couple of exercises using different combinations in which we were finding values of a specific functions, and then we were checking features of the function itself. This was done on video 1 and 2. Okay, so those answers are complete, and we've already checked each corresponding answer to each of those exercises. After that, we began with exponential equations, and the secret here was about this important note that I repeated many times. We need to have the same base to be able to work with the indices. Okay, so the secret around solving equations that are using indices as variables is by having the same base. Okay, so that's where the secret is. And we even solved a few exercises. Let me go back to the summary of those exercises just to confirm with you guys that we have the same idea. Over here you can see what I did in the previous video, video number 3. Take a look how, let me rearrange this. Okay, the secret was, if they don't have the same base, then we can change 32 as 2 with a power 5. Once they have the same base, then we can focus on the indices, so x equals 5. It was the same thing on the right side. Take a look how we have 1/9. That 1/9, we changed that as 3 with a power -2. Once they both have the same base, then we were able to work with the index. And that's how we got x minus 2 equals -2, and the answer that was x equals 0. This is something that we did already in video 3, and the idea is that for you guys to feel comfortable with the process, once again, the secret is on the important note. They must have the same base. If they don't have the same base, it's very difficult to find the answer. And we even solved a couple more. Let me go back to the solution of those exercises that we did together. So we have the solution here. And what I mentioned at that point is, for example, in this case, we have very different numbers there with different bases. So we divided by 6 over here. Now that we have a 9, the 9 can be changed as 3 with the power 2. And now that they share the same base, the answer is x equals 2. And then finally, the exercise on the right, maybe the biggest one we did on the last video, in which we were changing both the 4 changed into a 2 with a power 2, and the 1/2 that changed as 2 with a power -1. Once that was ready, take a look at this step in which they share the same base. Once the base is the same, we can work only with the powers or the indices, and that's how we got the answer x equals -1. So up to this point, I'm not saying that you guys are experts on exponential equations, but at least you know the idea, the expectation regarding the exercise itself. So now we can start the process of practicing by yourselves. So what I said last video is you have this huge list of exercises. You should try some. What I'm going to do right now is just show you guys answers to some of them. I was not expecting all of you to do the complete thing, but I'm going to show answers to most of them so you guys can compare on your notebooks if you have those answers available. So let's see a few exercises. For example, from the first section, so it says solve for x. So let me solve a few so you guys can see what is the expectation in terms of the solution. So for example, let's imagine the case for this one. 2 with the power x equals 8. They don't have the same base, so we have to change the 8 as 2 with a power. That works for us. In this case, 2 with the power 3 is going to be 8. Remember, 2 times 2 times 2 equals 8. Now that they both share the same base, we can focus only on the index, so x equals 3. Don't forget that the whole deal here is that we follow the recommendation. If they share the same base, you can focus on the index. So the 3 has to be the same as the x, so that's how we know that the answer is x equals 3. Let's do another one. Remember that the whole deal is to practice how this works. So we have 5x plus 2 equals 25. They don't have the same base, so what we can do is change to 25. Instead of 25, we can write it down as 5 with the power 2. And once they share the same base, then you can focus on the base only. And that's how I'm going to focus on x plus 2 equals 2. And if I move the 2 to the other side, I know that the answer is x equals 0. Okay? So once again, let me review what's happening here. They don't have the same base at the beginning. I make a small change such that both of them will have a 5. Once they share the same base, I can take the indices only. So x plus 2 equals 2, and that's how I know that the answer is x equals 0. Okay? And then finally, let me do one more here. Let's talk about this one. 5 with the power x equals 1. And what I'm going to do is change the base. Remember that a 1 comes from power 0. So 5 with the power 0 equals 1. I'm doing this change so they both have the same base, and from there we have that x equals 0. Once again, I'm following the note. If we can make the base numbers the same, then we can equate the indices. And that's how we know now that the answer is x equals 0. Okay? And that's how we've been working this process. Okay? So those are the first 3 of this section. Let me work with a few more. Let's see if we can find some extra answers here. For example, let's do another one that is a little bit bigger. Let's imagine maybe this one. This one is a large one. So let's see if we can solve this one together. So we have 1/3 with the power 2 minus x equals 9. So I'm going to change the base, so everyone has the same base, so we're going to change the parentheses as 3 with a -1. That's 1/3, and then 2 minus x. And we're going to change the 9 as 3 with a power 2. Now it looks like they both have the same base. I'm going to split this in half so I can continue on the other side. And now let's continue with the exercise. We have power of a power, so that means 3 -1 parentheses 2 minus x equals 3 with a power 2. And from there, remember that if they share the same power, we can work only with the indices. So what we have here is -1 parentheses 2 minus x equals 2. And from here, we can expand the brackets. We have -2 plus x equals 2, and the answer is 4. So this is the expectation. My idea is that you guys are able to solve exercises like this one, big exponential equations. If you feel, look at that, I'm repeating a lot right here. I'm repeating always. If they have the same base, try it. If you have the same base, try it. If they have the same base, then you can equate the indices. So this is a very, very good example of my expectation with you guys in terms of what we need you guys to be able to do by yourselves, okay? And let's see if you can try more by yourselves. I mean, there's lots of exercises from A to P. I'm showing you guys the answers for some so you guys can try this by yourselves. Remember that you can click on pause, try a few, and then check with people around you. The idea is that you can compare the answers with the rest of the class. Okay? Now let me move to part number 2. On part number 2, what you have is a set of exercises, a little bit more difficult because they have more information involved. But, I mean, you guys should be perfectly fine in terms of how to solve any of those exercises. For example, number 2. So we have 6 multiplied by 2x plus 2 equals 24. So what I'm going to do is that I'm going to divide by 6 on the other side, so we can eliminate that 6 from there. So 24 divided by 6 is 4. So what we have is 2x plus 2. 24 divided by 6 is 4. Let's move to the other side. And remember that we need both of them to have the same power. So we have 2x plus 2 equals 4, but 4 can be changed as 2 to the power 2. And then, now that they have the same base, we can work with the index by itself, and that's how we know that the answer equals 0. Okay, so at some point, the idea is that you feel comfortable with the process. I'm not expecting you guys to do this perfectly without any mistakes, because this is your first week working with them, but at least you feel that you can do the process of changing the bases, simplifying, finding the solution by focusing on the index. Take a look that at this point, once they have the same base, I can just focus on the index itself. Okay, we're using this note as a reference. Okay, let's try another one. Once again, I'm expecting you guys to be able to do this by yourselves, so the idea is that you try some of the exercises. For example, let's see, let me try this one, I. So we have 9x minus 2 equals 1/3 with 3x minus 1. So let's change bases. Instead of a 9, we can change 9 as 3 with the power 2. And instead of 1/3, we can change that as 3 with a negative 1. Okay, and as you have this, we can rewrite the expression. Now we're going to rewrite by eliminating parentheses, so we have 3 as a base, 2 parentheses x minus 2. Remember that we have there a power of a power, and on the right side we have 3, negative 1, 3x minus 1. So the whole deal is that they share the same base. Once they have the same base, we can focus only on the power. So we have 2x minus 2 parentheses equals negative 1, 3x minus 1. Okay, we can eliminate parentheses by expansion, so that will be 2x minus 4 equals negative 3x plus 1. And once you simplify, the 3 goes on the other side, the 4 goes on the other side, so we have 5x equals 5, and finally x equals 1. Okay, I do understand that I'm working a little bit fast at this point. This is our final video, so I'm expecting you guys to do this more fluently, efficiently, without any problems. If you need to make a pause, rewatch each and every one of those steps, that's perfectly fine. But the whole expectation is that at some point you guys feel that you can do this without watching what I do, that you can do this by yourselves. Now, as you can see here, I'm just solving a few for each one of the sections. My expectation is that you guys do the complete list, okay? So it's perfectly fine if you don't finish, if you don't have enough time, but you should try them all. On these assignment, you will see that I'm adding the solution to this practice, so you can use the solution to guide yourselves to see if you're doing this correctly. Once again, try them all. You can see here that I'm giving you the answer to some of them, so you can use the answer as a reference, but I'm expecting you to try them all. So once again, the video is not showing all the answers or not showing all the step-by-step solution, but you will have access to the answers because I will place the answer on Google Classroom, okay? So once again, please try it. You guys can do this by yourselves. It's just about showing independence and that you can see the step-by-step process. And up to this point, don't forget that this note is the most important one. If they have the same base, then you can definitely focus on the index only. Okay, and finally, just for those of you who finished all the practice, I am giving you guys a few questions from past papers. So this is an exam from 2025. This is non-calculator. I have here a few questions for you guys. This is completely independent work. I'm pretty sure you guys will be able to simplify and find the answer to each one of them. I'm gonna give you guys a few minutes to do this without my help. I'm gonna place the answers also on Google Classroom so you guys can try it, see how you guys feel, and don't forget that this year in October you guys will be answering questions like this one. This is one option, or the other option is this one over here. So those are questions in which I definitely feel you guys should be able to feel comfortable with. You guys should be able to solve this, especially thinking about October, okay? I will be leaving the answers on the document that it will be called Solution to the Practice, but I'm not going to show the step-by-step here because if I give you the answer on the video, then you guys will not try this by yourselves. So my expectation is that you see the exercises and you try them by yourselves, okay? So let me make a recap of what is my expectation right now. You have all the exercises that were left at the end of video number 3. So you guys should have all those exercises with the corresponding solution. Remember that I will give you the answer on a separate file so you can check each one of the solutions. And then finally, once you finish with that, my expectation is that you guys are able to solve past papers with questions related to it. So for example, I have an exercise here, A, B, C, and D. Please be sure to answer those 4. And then once you're ready, let's continue with the question on the next page. The whole deal is to see you guys working this by yourselves closer to what the expectation is in the IGCSE, especially now that in October you guys will be doing your final assessment, okay? So once again, guys, feel free to try it. Don't be afraid. Answers will be available, and of course, at any point, if you have questions, you have people around you that can help you. But I will be back on Monday, so we'll be discussing answers to this practice. But the whole deal is about you guys engaging on the exercises, feeling comfortable with the new topic. And also, I would like to appreciate your help throughout this week in which you guys have been doing a great job of working by yourself. So please try it, and remember, answers available on Google Classroom. Please enjoy and see you next week. Bye-bye.